Hi everyone, and welcome back to our work on congruence and similarity. Today we're going to be learning about how to find unknown angles and sides of similar figures. Okay, so the first question I want you to think about is what is special about the sides and angles in similar triangles. Okay, now hopefully by now you know that the matching sides are in the same ratio. And the matching angles are equal. Okay, and that's really, really important. In fact, those are the two things that show whether similarity exists or not. Okay, so if you can show that the matching sides in the figures are in the same ratio, or all the matching angles are equal, then either one of those two things, you've shown that the figures are similar. So let's have a look. Like, we can use that to help us find out missing sides and angles in similar figures. Okay, so let's have a look at some of these questions. Let's have a look at the first one. It says ABCD, that's this shape here, rectangle, is similar to PQRS. Remember, that's what the three vertical lines mean. They mean is similar to. Okay, and they want us to find the value of x. Okay, so I'm going to show you how to do it, how I would do it, and then I'll show you what this particular textbook used, and we'll see how we go. Okay, remember to write down any questions on your sheet so that you can ask me in class tomorrow. Okay, here we go. Now I can see that this big side here, PQ or x, matches with this side AB here. So I'm going to go x over 8 is going to actually be in the same ratio as 4.5 over 3. And I want to get x, so I'm going to times both sides by 8. I'm going to times this side by 8 and this side by 8. And when I figure out what that is, so if I just get my calculator now, here it is, I'm pulling it up. Make sure your calculator is in degree mode. So I'm going to type in 4.5 divided by 3 equals, and then times that by 8, and I get 12. Okay, so x is equal to 12 centimeters from doing it that way. So checking the way that they did it, now I started with the big side because I wanted to find x, but in their solution they had x is the same as 8. X things to 8 things and 4.5 things to 3 things. So changing them as fractions. So I just went to that first. And we've got the same answer. Okay, so either way you want to do it, they're actually starting with ratios because it's matching, sides are in the same ratios. So they write them as ratios. But remember, ratios are just fractions. So I just started using fractions. It's up to you which way you do it. Okay, make sure you write down at least one of those two ways. Probably the one you preferred. Let's have a look at the second example together. We're going to do a similar thing. It says, in this question, it says triangle ABC is similar to triangle MPQ, and they want us to find MP. Okay, so let's have a look at it this time. This time, I'm trying to find MP, and that's x centimeters. So I'm going to go x over, so I started in the small one, and the matching side's 4, or AB. And I'm going to say that that is equal to, coming back to the triangle I started in, 3 over 6, or a half. Okay, so just writing it out simpler. To get x by itself, I'm going to need to times both sides by 4, and that will give me x is equal to 2, and it's centimeters. So I've written my units on. Okay, let's have a look at how they did it. They used the ratio of sides, wrote them as fractions, as I did, and then they solved those to get the answer. Okay, now the question asks for you to find MP, so you'd then go at the end, therefore MP is 2 centimeters. Okay, Again, write out one of the two ways. They're actually both the same way. Their way just has a precursor first. Okay, last example for now. It says if the following triangle is similar, calculate the missing pronumeral. So these two triangles are similar and they want us to get x. So I'm going to start off by matching the sides. X over, so that side there matches with this side here, 9, is equal to, now x is in the bigger one, so I need to get this whole side length here, which is actually 20 plus 10. So that whole thing is 30 meters there. So it equals to 30 over the little one, which was 20. Okay, or x over 9 is 3 over 2, and I want to get x by itself, so I'm going to times this side by 9 and this side by 9. These cancel to give 1, so x is going to equal 3 times 9, which is 27 over 2. Now, before I go on any further, I just realized something that I've missed. Can you see what it is? Which is going to change all of this dramatically. And I'll point it out to you in case you haven't figured it out yet. But you probably have, because you're all pretty smart cookies. These are in centimeters, but these are in meters. And this is not going to work unless I get them into the same units. Okay? How many centimeters in a meter? 100. So if I times this by 100, I add on 2 zeros. And if I times this by 100, I add on 2 zeros. Which means same thing here. So let's do this again. Now those are in the same unit, so that's fine. So I'm actually going to have 3,000 over 2,000. Okay. Now when I do that, all these zeros still cancel out. So I actually end up with the same thing, but I do need to make sure that I'm doing it the right way. Okay. And I wasn't doing it the right way before. So we still end up with the same thing. So 3 times 9 is 27 over 2. But my answer is in centimeters, not meters. Okay. And you could figure out what that is if you wish. Okay, so write a summary of what we learned today. Any questions you have, and bring your booklet with you to class. Today we've learned about finding missing sides using similar figures. You can also find missing angles. And we've done some of that before already. So pause the video if you need to, and fill in the things that you understand, fill in the things that you don't understand as well, and ask me any questions in class. See you soon.